live.
Cool. Do you need to do any pre-roll? No. Well, sort of. He mentioned that Kroger had something, but.
So, thank you all for coming out tonight, especially the people who are here for the first time. We're starting about 5 minutes late. We are recording. It's going up on YouTube right now. This is a much easier way for me to get all the recordings up there. So afterwards, it's going to help us put the chairs away and keep everything clean. I don't think there's a cleaning crew who comes in with these anymore, but I'm sure that there's leftover pizza. I really don't need it. Feel free to take anything you have that we have left over back home with you. What else?
Just arrow.
Upcoming things. 2 weeks is Google I/O. Other than 2 weeks, is it 2 weeks, 3 weeks?
It's 3 weeks.
3 weeks? Okay, 3 weeks.
That's like me.
Yeah.
Scared me there.
After I/O, so next month, speed up, we'll do lightning talks. It's about kind of the same format we did last year, where we get a handful of people. They can come up and give a 10-minute talk on something that they are not an expert in because it was just announced 6 days ago. If anyone is interested in doing this, feel free to talk to me and Greg. It's, you don't have to be the subject matter expert in it because no one is, because it was announced 6 days ago. So, and it's a great way to kind of go here and just start practicing a little bit of public speaking.
Plus, you get to really learn new technology. It's a good opportunity to do that. I did one last year. It was a lot of fun.
We're always looking for presenters. We've got May covered. I can't remember if we have June covered.
I don't think so.
Okay. So if you're interested in presenting in June, let Greg or myself know, or after that. If you have an idea and just kind of want to bounce it off us, feel free to reach out. Glad to help however we can. A bunch of us usually go over to Rusty Bucket after the presentation, just to kind of socialize and network and chat and see how things are going. So everyone is always welcome to join us there. Is anyone hiring right now or looking to be hired?
That's what I mentioned earlier. Like I said, Kroger is hiring, like, they're looking for 5 Android developers right now, like experienced Android developers. The hiring manager's name is Kirkendall. He's Craig Kirkendall's brother. So if you're interested, like I said, let me know and I'll give you his contact information.
We do like feedback. It's something that we look at. You can either take your time to scan in that giant 4-foot QR code or go to bit.ly/GPG Cincy survey.
I'll bring it back up at the end of the presentation so
perfect.
they can scan again.
Yeah. And that's all I have. So I'm going to let Stuart start talking about how to do TDD for Flutter.
All right. Hello, everybody. My name's Stuart. I'm a software developer over at StackCT. StackCT is a website that helps construction contractors estimate the cost of doing particular jobs and annotate blueprints and that sort of stuff. I graduated from Grove City College in 2016 in computer science, and I'm known to sometimes wear cowboy boots occasionally. So anyways. So jumping right in, you guys are here, ladies and everybody is here to see TDD implemented in Flutter and Dart. So if you're not familiar, the Flutter SDK is a cross-platform mobile SDK from Google, and it's one of its primary benefits, selling points, is that it's designed for building iOS and Android apps from a single code base, which is something that many organizations have tried to solve with React Native or Xamarin, Unity, that sort of stuff. They recently shipped 1.0 at the end of last year, and the framework and the apps that you write with the framework are written in Dart. And it supports interop with Java, Kotlin on the Android side, or Objective-C and Swift on the iOS side. And it supports calling platform-specific APIs. And additionally, another one of the huge benefits of using Flutter is that it has a feature of supporting hot reloads, which is effectively, if you've been an Android developer for a little while, before the days of, what was that lightning bolt called? I forget. What was it? Instant Run. So before the days of Instant Run, you'd have to change your layout file and then completely restart the app, and it was, good minute, get up, get coffee, come back. Then they added Instant Run, which was definitely a benefit. Flutter supports hot reload, which is, as I heard Patrick saying earlier, it's basically instantaneous. It's like a half second. So you think of it as you're changing your layout, how you want your buttons or widgets or whatnot arranged on the screen. Change your code, press a button, it's on your phone, like that fast. So it is phenomenal for UI prototyping and even just fast development UI side. So it's really awesome. So we can't do TDD without a project to test. So I will talk about that in the slide after this slide. But first, so this was a chart from the Flutter developer website, and I just wanted to, before we get going, I just wanted to talk about the three main types of testing that you can do through Flutter and Dart. And again, this is ripped right from the Flutter website. The link's down below. So you've got basic unit tests, which are generally pretty simplistic. They run very quickly. But they're testing small bits of code, individual functions, that type of stuff. Next, you've got widget testing, which is kind of an intermediate between unit and integration. They run a little bit slower, but they definitely help with just testing that things are working together with your widgets. And then full integration testing, which I believe is referring to like, if you've used Espresso, something to that effect, integration testing. So it's just kind of interesting because the unit tests and the integration tests I've been familiar with from working on different previous projects, but the widget test is kind of feels like a new category for me as a mobile developer, and it's quite cool. I mean, so we'll get into that. All right, so now we talk about the project that we're going to be testing. So I work on a project called rotor.ai. It's myself and a friend here in Cincinnati, and it's an open source autonomous driving project. We started back in 2018. It was kind of we originally started as a hack day project, and we just recently achieved level 0 autonomy. Which if you've looked at the SAE scale for autonomous driving, level 0 is just manual driving. So autonomy. There was a lot of prep work that had to go in to set up the code infrastructure to be able to control our RC car. So that's why that was an achievement. It was so many things that we had to pave the way for before we could even just get it rolling. The project itself is composed of 3 smaller projects. We have an Arduino code base, a Raspberry Pi Android app, which runs on the vehicle, and Android iOS app, which is what we'll be working with tonight, which is written in Flutter. And before we go any further, I'm going to try to do a demo while everything is still hooked up, because who knows that this will last until the end of the presentation. So let's see. So here I have my Pixel 3 on the left, and then on the right I have my Raspberry Pi, which is running just below on the stand here. So I'll go ahead and start up the rotor vehicle code and send that to the Pi. And then while that's warming up, I will start the Flutter client, which is what we'll be working with tonight. Give it just a second. There we go. And on the right, you'll see it starts up, and it gives us a quick log of some of the stuff that it's done. Let me go ahead and start that. My phone right away starts scanning for Bluetooth LE devices. Somebody has a ceramic mug that has Bluetooth. So we're going to go ahead and select vehicle. It connects, and this is just a basic controller, not in the sense of like a UI controller, but literally like a handheld controller. So we have right in the middle is just an output of commands that we're sending to the device. We start off by sending just a neutral code, which stops the vehicle if it's moving, just puts it at rest. And as I press these buttons, we can see that it's sending commands over Bluetooth LE using a GAT server, using a characteristic. And you can see it on the right. The logs are coming out here. Now, because my Pi isn't connected to an actual vehicle, it's not actually sending anything over I2C. But if I had the actual vehicle with me, it would be, presumably. So anyways, we're just going to go through a couple of the particular places of interest for testing on the client. I just wanted to point out this. So this is the rotor command format that we use. So it's how many? 6, 7, 8, 9 characters, and it just indicates the. Let me make it a little bit bigger here. It just indicates the throttle value, the throttle direction, the heading value, and the heading direction. So think of it as controlling which way the wheels are going to be turning and how far, and then controlling how fast the motor should be moving and in what direction, forward or back. So again, that's why you see a N0 at the top, just because we want to set everything to neutral when we're starting out. Okay, demo is done. I wanted to get that out of the way. Okay. All right. So one of the classes that I was working with that was the class that I was working with on this project that was a great example thus far was the rotor command class, which is what contains. Whoa, that was close. The class that contains the values for that rotor command, the nine character string. There were a couple of things that we need to have, and there was one thing we should have. So we must have a class that represents a throttle and steering values, preferably immutably. We must have, it must construct, the default constructor must set everything to neutral. If you just ask it to build a new command, it should build it as N0. It must have a method that can encode those values into that 9 character string. And it should sanitize values upon construction. So if you were to try to construct a rotor command with F plus 1000, it should truncate that to a actual value that would work. The values for the throttle and the heading are both positive integers between 0 and 100. So that's the acceptable range. If somebody tries to construct a rotor command with a -10, it should truncate it to 0. That is the wrong button. There we go. Okay, so that was supposed to be an emoji, but it didn't show up. It's okay. This is kind of generally the layout that I kind of use sometimes at work when trying to implement TDD. I'll split my editor in half and put the code on one side and the test on the other side, and develop them in sync. Also, just wanted to mention, I've made Git tags for these, so you can go clone the project, and there's a separate branch just for this presentation, and you can do Git checkout the tag name, and it will take you to the relevant edits for the particular slide. So, anyways, so we're going to go ahead and define our rotor command here. We've got 2 integers, throttle value and heading value. And we've got 2 final values, which are a throttle direction, this is an enum, and a heading direction, which is also an enum. and this is our constructor right here. Now, Dart has a way of, I think it's called like named parameters or something to that effect, but it allows you to basically define when you're constructing. You can say new rotor command. I want this value to be this. I want this value to be this, et cetera, et cetera. We'll see it as we keep going. But at any rate, so this constructor takes in 4 different values, and it directly assigns them to throttle value, heading value, and then those 2 enums. It just takes whatever it gets, puts it in those variables. So our quick test, or a simple test that we could write, would be we should construct the rotor command with default values that we expect, so neutral, neutral. We're going to go ahead and make a rotor command. Dart supports the typical var auto typing that you're probably familiar with, or intelligent typing, or whatever it's called, from like Kotlin or Swift or whatnot. So anyways, arrange, we're going to set up our rotor command, and then we're going to expect, which is the equivalent of assert, expect the following values. So we expect that the throttle value should be 0, the heading value should be 0, and the throttle direction and the heading direction should both be neutral. Will this pass? Anybody want to take a crack at it? No. Is correct. It is going to fail right here. So something I should mention is because I put these parameters in squiggly brackets, I can construct a rotor command without providing those particular values. So they're like optional values, so to speak, or like, you can have them or you can omit them. So in this case, I've constructed a rotor command and given it nothing. So this should fail right here. Well, let's go ahead and implement the code that can get us through that. We can set default values if they're not provided. So for throttle value and heading value, 0, 0. And then for throttle direction and heading direction will be neutral, neutral. So that's kind of just that's like the most basic, just setting up a test and expecting certain values to come back. And kind of gives you a quick tour of being able to construct an object and set default values and that type of stuff. If anybody's wondering, there's no particular reason I put these 2s up there because I was trying to get the test to fail earlier, and it's not particularly relevant. So you could omit these 2s if you want. OK, so next test for the same class, we're going to go ahead and try to format some of the strings. So we're going to try to build the second half of the command, which is representing the throttle value and the throttle direction. In this case, we're particularly testing the value. We want to encode it as 3 individual digits. So even if its value is just 1, it should be 001. If it's 100, it should be 100. If it's 11, it should be 011. So we want to make sure that we have all those correct. In this case, we're setting up our expect statements, and we're actually just constructing a new rotor command directly in there, just kind of in line. An interesting tidbit, Dart used to require the new operator, kind of like Java. They removed that, I think, at Dart 2 or 2.1 or something like that. So at this point, it's optional. You can leave it out. I just wanted to mention that they did used to have a new operator, and they've since made it optional. So at any rate, let's see. So this is our method that we're testing directly, throttle to shorthand. Shorthand is just my name for encoding it, really. We're building an abbreviation, and I've shortened this. This is basically setting the first character. So the logic there is hidden because it's not relevant right now. But and then we're returning a character plus a throttle val to string. Now remember, throttle val is an integer. So what do you think is going to happen when we run this first expect? Anybody? It should fail. It should fail, and I would wager it would return a expected N0 instead of N000. Oh, I think I might have been running this. So I might have been running this with the. Actually, that's an interesting thing. Let's go ahead and check that out right now. So if I go ahead and get checkout TDD0. Okay. Oh wait, is it TDD1? I think it's TDD1. All right. So we are working on the throttle2 shorthand. This is the abbreviated part. This is just a switch for setting, which integer. And it is tested. It's just in a separate test. I wasn't going to go into it right now. Let's make this match what we have on the slide. So that was throttle val2 string. Throttle val2 string. And let's go ahead and run Flutter. So you can run, Flutter allows you to run individual files. You can run like a whole test file itself. You can run the whole test suite. You can run just an individual test by itself. So that's what I'll go ahead and do now. So Flutter test -- plain name equals, and I want to do should produce correct shorthand for throttle value. Should produce correct shorthand for throttle value. So let's go ahead and take that, plop it right in there. Oh, was I? Good call. All right, so we go ahead and run that, and we get, it was expecting N000, so it's the 3 digits that we need, but it instead got an N0. So in this case, I'm fast forwarding a little bit, but the solution for implementing this and passing the test is to run a format int function that I've written below. So that Dart Flutter has a way of just it's kind of like, Java has formatters. So Dart, you can just run a number formatter. I say that it must have a minimum and a maximum of 3 digits at all times, and I'm just gonna call that method format int throttle val. And we'll go ahead and rerun our test. It's just running the one test that we want. And boom, get a +1, all tests pass. Awesome. And now we can run the whole test file if we want to as well. So this is, to run a whole test file, just name the path of the test relative to your current directory, I presume. Flutter test test/data/ rotor command test.dart. All right, all four tests passed. Cool. So anyways, that's a quick preview of what it looks like when, failing a test, changing some stuff, making it pass. All well and good. And quick tidbit as well while I'm here. Dart uses underscore syntax to make methods private. So there isn't really a private string. It's just string underscore function name. So this format int is private to this class. All right. All right, so now we want to clamp the values. We want to keep them between 0 and 100, just so that our car doesn't do anything crazy. We're going to go ahead and give it a test scenario, giving it a negative value and a positive value for both the throttle and the heading directions. And we should expect 0, 100, 0, 100 for those results. And upon running said code, we end up with, hey, look, it's expected 0, and you gave it a -10, because our constructor is just literally taking whatever it gets and assigning it, and then that's it. There's no validation at this point. So there's a lot of changes here. I'll try to parse it out real quick. Effectively, what I did was I made the throttle value and the heading values private. So I gave it an underscore, so now they're private to that class. And I made a getter for the throttle value and the heading value. And the reason for this is because I want to be able to take in the throttle value and adjust it before I assign it inside my class. So in this case, now instead of directly setting those values, remember before it said this dot throttle value blah blah blah, that was directly assigning it into that instance up top. Now instead we're taking it in as a traditional parameter, and I am then assigning the actual value to a clamped version of what I was given. So this dot underbar throttle value is going to be throttle value dot clamp. This clamp is provided either by Flutter or Dart, so just kind of a nice built-in thing. So that's just another quick example of kind of setting up a quick unit test. And the other cool thing is we've now accomplished one of our goals. We've made our values immutable, which is what we were kind of wanting to do on the slide way up there. So when we construct a rotor command, we assign it values, and that's it. That's what it has for its lifetime. It's immutable. You can pass it around, whatever. So if we try to run this particular snippet of code, which is just creating a rotor command and then trying to assign the throttle value, it can't. It's immutable. It's hitting the getter method that we made instead of hitting the actual integer value at this point. So previously, a couple slides back, if we had run that code, you could just override the values at whim. But now that we've made it private and given a getter, it's one way. So, all right. So fast forwarding a little bit more, we're going to build up the entire command string that we saw on my phone there. So we've got two different main segments. Remember, we've got the throttle values and the heading values, and they have similar encoding patterns, really. So I've skipped through those tests. But we're going to go ahead and set up a unit test here that will test two different commands and just assert that they output the correct encoded strings. So in this case, we're creating a command A. And this is what I was trying to elaborate on earlier. These parameters, they're labeled. You can actually label them. That's kind of how they're put together, is you can label them as you're constructing it. So you know kind of what you're talking about. Anyways, so for this first command, we're giving it a throttle direction of forward, a value of 77, and a heading direction of port, because I was feeling silly and I wanted to use port and starboard instead of left and right. So anyways. So we're setting up the values there on that first command. We're setting up a different set of values on the second command. We are retrieving the shorthand encoded version. That's the act stage. And then finally asserting that our values are what we expect them to be. So right now our toShorthand method is returning just an empty string, so it's going to fail. And it's going to go ahead and say, hey, look, I expected F077, space L, and I actually got just a space. What the heck? These are actually different. Surprising. And we can go ahead and just concatenate those two methods together, and we're golden. Now, technically, this is sort of where I go back and forth on TDD, is you could kind of argue that you could have an intermediate step in here. If once you see that, oh, it's expecting F077, blah, 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 I'll just make this method return that exact string, and that assertion will pass. Well, yes, you are correct. And so that's where I'm kind of like, when you're writing TDD for methods, it's sometimes what I do is I do set up the test, assert that this happens, or that this returns. Make the function literally return just that one static string or value. Oh, look, the test passes. Great. And then you add to your test a second condition, or a second command in this case. Oh, I'm going to change up the variables now. All right, now you still need to return me the correct encoded string. Oh, well, now I can't return a hard-coded string up there. I actually have to do the real work. So anyways, that's where I'm like, it's kind of up to interpretation, I suppose, but that's kind of a general good rule, if you can, is to set up at least like two situations like that. Okay, whew. So now we're out of the more simplistic testing. We're going to try to get into mocking a little bit. So there is Mockito for Dart. I don't know that it's exactly like organizationally related to the real Mockito, but they named it Mockito and it works the same. So anyways, if you've used Mockito in Kotlin or Java, you'll feel pretty at home here. You use a typical when mock.method, then return the thing that you want to return. And it also has support for mocking futures as well, which was particularly handy because the Bluetooth library that I was working with had a lot of future stuff because there's just a lot of async stuff going on. And of course, it allows you to verify calls, so you can verify that a method was called, or you can verify that a method was not called. I think you can add an integer here, I'm guessing, to like, oh, this method was called 2 times or 3 times. So at any rate, the links are down below as well. The Flutter website themselves has documentation on using Mockito. So anyways, you add it to your project just like you would for Gradle. Flutter uses a pubspec.yaml file instead of a .gradle file, but it's the same principle. You're just adding a dependency and letting it collect everything. So, okay, so let's set up a simple a test using a mock. So, in this situation, we would like to test that when we're collecting data, when we're scanning through all the Bluetooth devices that are in this room, for some reason or other, it's possible that we could get multiple results with the same MAC address. And we don't want to just keep adding the same MAC address, similar device or same device with the same MAC address to our list that we are building up. So anyways, to go about this, we're just setting up a mock Flutter Blue. So Flutter Blue is the Bluetooth library for Flutter that I'm using, and supports iOS as well as Android. And so in this case, I'm putting together a mock of that Flutter Blue object that I need. And I'm building up a scan result. This is a real scan result, not a mock scan result, but it is using a mock device. So there's another class from the Bluetooth library that represents a Bluetooth device. And so we are mocking out a particular device. And in this case, we're setting up 2 devices with the same MAC address with different names for the purpose of the test. OK, so one of the main first steps with setting up a mock in Dart is they kind of use this format. I don't know how else to explain it. You basically define a class that extends mock and implements the class that you are mocking. So in this case, we're mocking a Bluetooth device. So what the current implementation that I have for this is a dedicated mocks class in Dart. It's just a rotormocks.dart file. And that's where I've just put all my mocked classes that I've put together. Next, this is a helper method that's used in this test over here. And it's just asking, hey, I want to build a mock Bluetooth device given this name and given this MAC address, like you see across. So we're going to go ahead and build up a var device, mock Bluetooth device. And we're going to say when somebody asks you for the name of this device, return X. In this case, the name that was provided. And when somebody asks you for the ID for this device, return this other thing. And that's it. Return the device, and we're good to go. So anyways. OK. If anybody could please stand up now.
What Bluetooth device class or interface?
I'm not sure. We could take a look at that real fast. Where was this? Would be, let me flip status. Get. OK, so if I check out my rotormocks class, interesting. So this is in my Flutter SDK folder .pub cache hosted pub dart. This looks like no, it's actually a class. That's weird. Interesting. Yeah, so this, for example, this is the source code for the Bluetooth library that I'm using. If we take a look at another one, let's see, just mock Bluetooth device. This is again going to be part of the Flutter, the Bluetooth framework that I'm using. Yeah, it's again a class. So that's interesting.
So the implements isn't like the Java implements syntax or implementation?
Maybe. I'm not fully sure, but it's definitely, that's interesting. It's not an interface itself, at least it's defined as a class, so that's interesting. Good for pointing that out. It was, yeah. While we're in here, I guess I'll just go ahead and mention the format that I'm kind of using for the packaging is, let me fold all these down. So all your Dart source code in a Flutter app is going to be in the lib folder. That's for stuff that's going to be running on both platforms. And then there's a test folder as well. I've set up my test folder or subfolders to match that of my lib folder. So if I have a class in the data folder, I have a data folder down here. It's similar again to if you've done TDD on Java or Kotlin. And like I said, I have a dedicated mocks file right there. Anybody have any quick questions we've gotten so far in? Nope. Okay. Cool. All right. So mocking a future value. So this was kind of a pain, but it was something I needed to do, especially for using this. The SDK that I was using is called Flutter Blue. I don't know if I mentioned it, but anyways, the SDK uses a lot of futures when you're requesting attributes about a Bluetooth device or just trying to scan for devices. Well, scanning devices is a stream. That's a separate issue. But the SDK itself deals with a lot of futures where I would like to request this information, and eventually it'll come back. So at any rate, we're going to go ahead and try to put together a test that is mocking a future and returning a specific future value. So in this case, we're going to, I can't demo it really easily at the moment, but when I click a particular device to connect to it, it has a connecting wheel that spins, and it's like a little message box. So this is a widget. This is the widget that represents that. We are asking in this test that we should attempt to connect to the device upon building said widget. So as soon as the widget is built up, we should try to initiate a connection. Again, we're going to go ahead and build up a mock device and a mock Flutter Blue, so mocking out those two resources that we need. And I've got the class definitions down here. And I'm going to say when somebody asks this device for its current state, which is like connected, disconnected, connecting, whatever. When somebody asks for that future, I'm going to, instead of then return, it does then answer, and you provide it with a lambda expression. And I'm going to, in this case, I'm saying return a future dot value of Bluetooth device state disconnected, which is, I think, an enum for representing what the connection state is. So anyways, that's a real fast demo of being able to mock out and substitute a future value. In this case, I have a specific value that I want the future to represent right there. We're going to go ahead and set up our widget. Now that we've done all of the arrangement up top, we're going to start getting into the act stage. Our widget is right here, so BT connection dialog. We're going to give it our mock device and mock Flutter Blue. And then we're going to verify that the connect method was called on the mock Flutter Blue instance that we have up above. And if I recall correctly, we can verify that it was called with our mock device with any timeout value and an auto-connect Boolean of false. So asserting particular values were called that way. So yay, and we just built a widget test. I didn't even tell you about it really, but it was that was actually a widget test. If we look back at this, so this setting up a unit test is a little bit different than setting up a widget test. The main differences are instead of using just test, you're going to use test widgets. The test itself will be async, and we'll get into a lot of this setup right here for actually building up the widget in a test environment. So again, like I said, the green underline area is the widget itself. If you'll notice, I put all of this other boilerplate around it, and the reason being is I believe it needs that environment to correctly represent, in this case I'm using material design. So I'm putting a material app and scaffold around my widget rather than just trying to pump the widget by itself. I think I recall running into issues if I just tried to pump the widget by itself. So take it with a grain of salt. I don't know that this is the exact correct way to do it, but I'm pretty confident that there are dependencies that are not met if you don't encapsulate that when you run pump widget. And additionally, there's other methods on this tester that you can use. So there's pump widget, there's pump and wait, I believe, which will wait, I think, for animations to complete, something to that effect. Or you can use tester.pump just once or twice if you need to. I am not an expert on that, so I will defer to the documentation if you'd like to look into that more. But in this particular sense, I think probably the appropriate answer is don't use pump and wait unless you have to, because why not? So anyways. All right, so testing streams. So when we're sending those commands across Bluetooth, we want to send it as, I basically wanted to build up a stream of events, a stream of commands that we're going to be sending across when we push those buttons and the text comes down. So in this case, and this is, if you've worked with RxJava, this is kind of sort of similar, I would say. So it kind of think RxJava land a little bit. Anyways, so in this case, this is our actual class implementation. We have a command streamer, which is our object that's going to be handling the individual commands themselves. And we're going to, we have a stream controller inside that class. And it's going to be handling rotor command. So we're giving it that particular type. In this case, this is something that I implemented, but it's not required, I guess. But I had a private member for staged commands, so that allows us to stage a command that we're about to send, and then we can have a separate method for actually executing, send it across, send it onto the stream, actually go. And I've abbreviated. There's more down there, but I've abbreviated it. So putting together a quick test for this stream. Remember how I said when we start up the app the first time, we want it to send an N0 command so that it's all in a neutral state. The car is at rest when we start it up. So in this case, we're saying should initialize with default command in the stream, default command being N0. And we're going to go ahead and build a command streamer. We're going to go ahead and build a command streamer and a command stream from that command streamer. So let me back up, I guess. I believe this is allowing, so this is, so this is our class that we have on the left, and then this is the actual stream itself that we're just getting from a getter. And we're going to first just verify, hey, we expect that command stream is an instance of a stream that takes a rotor command. Then we're going to, this is the key part here for testing against streams, is we're doing an await command stream dot first. Again, think it's a little bit similar like RxJava. Await command stream first, then when dot then is like when the future completes, from my anecdotal experience. When the future completes, assert the following items. Assert that our first item is not null. Assert that it has a neutral throttle direction 0 and a heading direction of neutral and 0. So that's a quick example of putting together a test for asserting the first element is emitted from a stream. Now I do have a few other extra bonus point things. If we have time, okay. I didn't put slides in for these, but this will kind of just be ad hoc. Hey, look, it's still on. How about that? Okay. So I didn't for this project I didn't get to the third category of test, which was the integration test, I believe. But I believe there is documentation on the Flutter website for that. I glanced at it real quick. I believe it's to the effect of kind of I feel like it's probably espresso style type of stuff, just in the sense that it's actually running the app. Let me check Flutter testing. So again, there's a chart that we saw. The integration test is the one that I didn't get to. If we check out integration tests, integration testing. So we have a Flutter driver dependency. They're building up a quick app there. Creating a test file, instrument the app, and then actually getting to the test. This is kind of uncharted territory for me, to be honest. So I'll again defer to the documentation for you guys to check it out as extra reading. But I presume my presumption is that it's probably to the effect of kind of espresso testing in a sense. Again, don't quote me on that because I haven't done it before. So, at any rate, there's also a couple of nifty features that are provided through Android Studio and VS Code that allow you to quickly debug stuff as well. So, in VS Code, for example, let's see if I can pull it up. They just added a new feature that allows you to. It's a web browser-based Dart analyzer or Dart inspector or something to that effect. Let me see if I can pull it up if I run it. Oops. Okay. Whoops, that was the wrong button. All right. So just if you're curious, there's two different editors that are supported out of the box with Flutter. You can use Android Studio, which is very common, familiar with most Android developers. They also support VS Code, which is awesome because you can do this and make the text big, like really easy. But at any rate, I mean, come on. I use that quite a bit at work. Anyways, but they have plugins for both environments to run Dart and run Flutter. I'd say probably the plugin for Android Studio is a little more mature, I suppose, but that's just my 2 cents on it. Man, there used to be. Control plus, or on Mac it would probably be Command plus. And it actually scales the whole app, which I really like actually, because if I need more resolution, I just make it smaller, and it's like I have a bigger screen, kind of. Anyways, there was a pop-up that came up in the corner earlier that said, "Try out this new Flutter feature," and I.
Debugging session running.
Hmm?
You have to have a debugging session running.
Oh, do you?
Yeah.
Okay. At any rate, you can also run the Flutter app directly just by running flutter run. And there's various other commands as well for if you need to build a archive of your app, or if you need to create a new app, or get dependencies, that type of stuff. It's running through the Gradle build and then installing, and there we go. And it's up. Hooray! What else? What else can we take a look at? Do you happen to know where that was? How to bring it up?
Oh, I always use the gang sign P to bring up the actions menu and search for dev tools. But you have to have a session running.
Oh,
Like hit F5.
okay.
And it'll kick it off. Maybe search for like Dart dev tools.
There it is. Let's see if it brought it up. It brought it up on my browser previously. It was like a localhost web page.
Try again.
You must start your app with debugging. I admittedly don't know how to do that in VS Code, but I do know how to do that in Android Studio. If I switch projects here. Oh wait, actually, I think I can. 1 second. There we go. Can I run this as debug? Start debugging. Okay. Dart dev, open DevTools. Updating Dart DevTools. Now is not the time for an update. At any rate, it's. I looked at it for like 2 seconds the other day, but it seemed like it was a localhost web page that was going to allow you to do just additional debugging and helpful tools. Oh, there it is. I've never used this before, so I'm learning with you guys. It looks like I guess this is a widget tree. So showing you, in this case, on the page that I have up, which is just the title screen, I have a text and a raised button. Raised button is the material design version of just a button. So yeah, you can take a look at the widget tree there. I wonder if I go forward. If I go forward again. Ooh. So interesting side note. There is I added a vehicle simulator to our app just so that I can try to look at the following screen without actually having to connect. It's interesting to note, if you try, in this case it's throwing an exception, I believe, because it's trying to connect to a device that doesn't exist. Typically, if you're running that on a phone, it actually will throw the exception and still keep going. It doesn't really care. Either Flutter or the Bluetooth framework or something is throwing an exception and it just keeps on going. In this case, I guess it stopped because I have the debugger running, but I've just noticed that anecdotally is running that. I mean, it'll log it, of course, but yeah, it just keeps on going typically. So, at any rate. So there is a utility like this also in Android Studio. If we close this and go over to Android Studio, they have a Flutter sidebar in here as well. Again, I'm honestly pretty pretty new to this area of it. So I've been splitting my development time kind of 50-50, but maybe a little more in Android Studio, but at any rate, so that is take it with a grain of salt, I suppose. I guess also while we're here, if you're curious, setting up some of the theming stuff, I am quite liking how they set up themes for material design in Flutter. In this case, we had a designer friend of ours put together some swatches for us, and you can go ahead and define those swatches, define the primary color for those swatches, and then I have the actual theme right here. If I close that and change this from dark to light, we can take a look at what happens there. A lot of windows open right now. Did anybody have any questions or follow-ups or anything?
I have a question.
Yeah.
Since you're using a Bluetooth library in Flutter, have you tried other Bluetooth libraries and can compare whether using the Flutter plugin version is easier to use or harder to use, or saves you a lot of time? Or?
I've done classic Bluetooth on Android in a previous iteration of this project, and that was not super easy. I am liking this plugin or dependency that I'm using for Flutter. So it's been pretty straightforward in terms of the other nice thing about Dart is that the Dart language seems to be pretty well built for handling futures. And in the case of Bluetooth, you're doing a lot of futures because you're like, I need this information, but it may not come back right away. I need this other information, but it may not come back right away. And when it does come back, I need to do this other thing. So I've quite liked working with the existing SDK the dependency that I have. I haven't used any other Flutter Bluetooth libraries, if that's what you're asking.
There's one for Java, based on reactive Java or RX Java. I'm not sure what they call it. But are you familiar with that? Does that compare? Is it easier to use or harder to use?
I'm familiar with RX Java and I'm familiar with Bluetooth, but I'm not familiar with any Bluetooth RX Java libraries. Sorry. But at any rate, it was not terribly difficult in terms of, compared to the previous iteration of the same project, which was just Kotlin Java straight, by the book type of situation. I will say the other 2 cents here is that this implementation is using Bluetooth Low Energy, as compared to my previous iteration, which was using standard Bluetooth. So it's not quite an apples to apples comparison per se. And the setup was different. I can say from working with Bluetooth LE that it's pretty nice. Seems to work reasonably quick. So in this case, we're sending small little bits of data at a time, just those small strings. So we don't have a need for super huge bandwidth or anything. But so if you guys are interested, I can give you a quick demo of the hot reload feature as well. So let's put this up there, and let's pull this over here. And we'll see if this works, changing the theme from light to dark. Yeah, buddy. It's that easy to change the UI. Oh, I want it the other way. Boom. It doesn't even stop the app, it just keeps going. If I turn that off, to go forward. So I guess just another small thing while we're in here. Flutter has guides if you're familiar with if you've done iOS development or done Android development or web development before, they have guides for transitioning between classic Android and Flutter, which is really nice. I'd highly encourage you to take a look at it if you're interested. It's basically like, if you've done this before, this is how you do the similar thing. This is how you set up a linear layout equivalent in Flutter, et cetera, et cetera. So that's about all I got.